My name is Johannes Gussenbauer. I'm working at Statistics Austria, and I would like to give a short presentation on a package that we develop. It's used for standard area estimation on surveys with a rotating panel design. For instance, this EU Silk, which is used to estimate the poverty rates. And those surveys have some challenges. The first one would be that if you go to a subnational level, you generally have a poor accuracy. And the other main difficulty is that generally, if you have a complex sampling design and you have this panel rotation, then estimating standard errors can become very complex very quickly. So this is where this package should come into place, the surveysd package, which should help with those problems. So we're having, for the standard area estimation, we're using a bootstrapping technique. So we're not directly estimating estimates, but we're simulating them, so to say, and we're using this rescaled bootstrap from Preston 2009. And for this improved accuracy, we're using a very cheap, or let's say primitive trick, where it just average over the bootstrap replicates over consecutive waves. And this is very simple, but also very effective. And lastly, we try to make an R package that's really easy to use and really straightforward. Even if you're an R beginner, it should not be that difficult. So that was at least the goal. And now the main functionality, as I said, it's really straightforward. You draw your bootstrap replicates, you recalibrate them, and then you estimate standard errors. So that's basically it. So for the bootstrap replication, you just plug in your data basically, and then describe the structure of your data. And using this strata and cluster, you can easily, where's the button? Oh, there. Yeah, so using this strata and cluster, you can easily imply any sampling design you want. So it just takes 2-stage, 3-stage, 4-stage. It doesn't matter. They can be stratified, not stratified. It takes whatever you need. And the bootstrap replicates itself. They replicate this panel rotation. So they are similar to this rotating panel design that is in the original data. Now, if you have your bootstrap replicates generated, you then recalibrate. For this function, we just mainly use the wrapper for the IPU2 function from the SimPop package, basically because this is really cheap for numerical reasons. And if you have like 1,000 or 2,000 or 3,000 bootstrap replicates, this can take some time to recalibrate all of them. So the main use was to get something that's numerically easy to calculate. And as before, it's really flexible. You can define any variables you want to have the bootstrap replicates calibrated onto, and then you at the final step that is calculating the standard errors. So again, you plug in your data, you describe it a little bit, and then you just say, okay, I have a function, so a point estimate, and I want to have the point estimate applied on a variable. And you can put in multiple variables, and there are some point estimates predefined. But basically, you can define any point estimate you want, and you can borrow any point estimate from any other existing package and just plug it in. So there are also these other parameters where you can then define, okay, I want to do this averaging, then I specify this year mean, or I want to do this difference, then a bit between waves, then I can specify this year diff parameter. And for all these subgroups, where I said at the beginning that this is also a goal to get estimates on subgroups. You can specify any subgroups you want with this parameter crossvar, anyhow you want, and as many as you want. So this is how such a call could look like. We only have 10 bootstrap replicates for this example right now. I'm using, so I'm just plugging in the data, describing it a little bit, and then I say, okay, I want to have this weighted ratio on this poverty variable estimated, and I have this crossvar variable where I say, okay, I want to have it by region and by gender and region. And it computes really quickly, and you can get this verbose print option where you just get a little bit of information. What have you just done? How many point estimates were estimated? How many subgroups do you have? And so on, and a little bit on the accuracy as well. So as I said before, you can put in any point estimate you want. Here I'm using the Gini index, and I'm borrowing it from the Laken package. I'm just randomly generating some income variable because it's not in the data that I used, and then I just need this wrapper function because the function that the point estimate that you supply, it needs to return a single value, so a single integer or double value, and then it should work. So we do this, we plug in the Gini function and on the variable income, and I just throw in, just because this year diff parameter, and I want to have the quantize as well, And then again, I get this verbose print output where I can see what I've done so far. Yeah, and just for the just to give a bit of convenience, there's also some plot methods implemented. So you can plot your results, because if you've realized some of those results that you get back, you have like a couple hundreds or thousands of point estimates, and it's really difficult to get an overview. So there are some plot methods implemented where you can plot by a specific group and also compare by these groups. Or here we have the comparison by these regions compared to the national Gini index, for instance, for each year. And these ribbons, they're like the point estimate plus minus standard deviation. So you just get a little bit of an overview. It's just for convenience. So I think that concludes my talk. So this is the surveysd package. It's on GitHub. You can check it out. And if you have any like feedback or criticism, then please don't hesitate. We're still building it up, so we're thankful for any feedback. And we believe that it's simple to use. But if you have a different opinion, also please let us know, because we want many people to use it who are not really good at R. And yeah, that's it.